Okay, so we're going to start by talking about work. And work is defined as the energy that's transferred. And the way energy is transferred is by a force. So when we want to calculate the work, we are going to take the product of a force times a distance. So in this case here, W is the work or the energy transferred, and that will be in a unit of energy we call a joule. So a joule is a unit of energy. There's other units of energy, for example, a calorie, but we're going to work in joules. So W is the work, F is the force that's applied, and that of course is in newtons, and D is the distance over which the force is applied. So if a force doesn't cause an object to move, it has not transferred any energy, and the distance, of course, is in meters. So this is going to be our first equation. Anytime you want to find the work that is done or the energy that is transferred, one way you can do it is take the product of the force times the distance that the force acts. So the units of force are newtons, the units of distance are meters, and so a joule, one way to think about a joule, is that it equals 1 Newton meter. So a force of 1 Newton applied for a distance of 1 meter is 1 joule of energy transferred from one form of energy to another. Okay? So we'll do some calculations with that. The second equation we want to look at is how do you find kinetic energy. So we are going to call kinetic energy KE, and the kinetic energy is the energy of motion. And so the way it works out is that 1/2 of the mass times the velocity squared of an object will give you the kinetic energy. So that's another tool you can put in your toolbox. And these are probably familiar to you. This is a review. In this case here, the kinetic energy is the energy of motion. And when we talked about worth, we talked about how different things are worth different amounts. Different people's times, for example, are worth different amounts. When it comes to energy, energy of motion, this is how you work out what it's worth in terms of the grand scheme of energy. So it's 1/2 the mass times the velocity squared. And here we just got to be careful. The mass has got to be measured in kilograms, and the velocity, of course, has got to be measured in meters per second. And so the units of kinetic energy are going to be the units of mass, which is a kilogram, times the unit of velocity, which is a meter squared per second squared. Excuse me, velocity squared is meter squared per second squared. So that is a funny looking unit, but we can write it slightly different. I can write a kilogram meter per second squared times a meter. I just split up this meter squared here as a meter times a meter, and then this part right here is a newton. So that's a kilogram meter per second. That's a unit of mass times a unit of acceleration, which is a unit of force. So that's a newton times a meter, which is indeed a joule. So when we have energy, kinetic energy, the units still work out to be units of joules. So if something's in motion, you can calculate how much energy it has using this formula, and that would be how much energy it would take in order to get it moving. So that's our second equation we're going to use. The third equation we're going to use is potential energy, and we're going to call that PE, potential energy, and it's potential energy due to gravity. So sometimes you might see the notation U sub G. U is the symbol for potential energy sometimes, but we're going to use PE. And to calculate the energy of something that is in the air or up above the ground, we could say we're going to take M times G times H. So this is going to be our formula for potential energy, how we calculate the amount of energy something has because of its position in a gravitational field. So again, let's take a quick look at the units and what these things mean. In this case, PE is the potential or the stored energy in gravity. M, of course, is the mass, which is measured in kilograms, and H is the height above some reference line. So we have to pick a reference line for our measurement of the height, and the potential energy will always be measured relative to that reference. So let's take a quick look at the units. The units for potential energy will be the units of mass, so kilograms, the units of G, which are meters per second squared, and the units of H, which are meters. A kilogram meter per second squared is a Newton times a meter, which is again a joule. So the units for potential energy are also joules, which makes sense because these are all forms of energy. Potential energy, kinetic energy, and work as energy transferred. They're all measured in joules. So here's a conversion that's very handy to use. Oftentimes we're not used to measuring energy in joules, and a unit that is more familiar to us is the calorie, and these are both units of energy. And so the conversion that's handy to have, and you should put in your conversion book, is the fact that 4,186 joules is 1 calorie of energy. So a calorie was a unit of energy that chemists use a lot. It was used for heating experiments. 1 calorie was the amount of energy it took to raise 1 kilogram of water 1 degree Celsius. And that turns out to be the same as 4,186 joules. So write that conversion down because we're going to use it. So here's an example problem. Suppose I have a stroller and I'm going to take it on a jog. So here's my stroller, here's my person. It's kind of a big stroller. And they're going to push this stroller, and I want to know how much work do they do pushing the stroller. So the work equals the force times the distance the force moves the object. And in this case, the force I know is 150 newtons, and the distance is 5.0 miles. And immediately we recognize that that is the wrong unit. We need to convert that to meters, so we can quickly convert that to meters, and that is 8,045. So that's 8,045 meters. And so now we can find the work. It's the force, 150 newtons, times the distance, which is 8,045 meters. And we will find, in this case, the work that is done, which looks like about 1.2 times 10 to the 6th joules of work. Now we don't really have a good place in our head for that energy, so I'm going to do a quick conversion. I'm going to start with 1.2 times 10 to the 6th joules, and I'm going to convert it. I'm going to get rid of joules and get calories. 1 calorie is 4,186 joules. So if I do this calculation, I can figure out that that is really 290 calories. And so what this tells us is, in order to push the stroller around the block for 5 miles with a force of 150 newtons, we will do 290 calories of work on the stroller, which that's a number that's easy to fit in our heads. We know what 290 calories is. That's like a 6-inch sandwich from Subway. So oftentimes we convert energy from joules to calories just to give us a feel for how much energy that actually is. So basically, 1 6-inch sub from Subway will power our bodies to push a cart around a jogging stroller a distance of 5 miles. Other problem, another example, if we want to find the kinetic energy, for example, of something, we take 1/2 the mass times the velocity squared. So for a typical car, for example, that's going to be 1/2 the mass of the car. Let's go with about 2,000 kilograms. That's a typical mass for a car. And 60 miles an hour is about 26 meters per second, and that will be squared. So just to give you an idea of how the numbers work out, I get about 676,000 joules, which again, if I want a comparison, I can convert that quickly to calories, and figure out that's 161 calories. So it takes 161 calories of energy, of gasoline, to get a car going that's 2,000 kilograms, to get it going 26 meters per second, that velocity. So that's an example of how you might calculate the kinetic energy of something. It's 1/2 the mass times the velocity squared. And lastly, to do an example of potential energy, that equals m times g times h. And so if I walk to the top of the stadium, you can ask how much potential energy does my body have? So we will start with a person who has a mass of, let's say, 80 kilograms. G, of course, is 9.81 meters per second squared. And if we go to the tippy top of the stairs, so we start down here at the bottom, and we end up at the top of a bunch of stairs up here. H is the height that we've gone, so we're up here now. There we are. The height of the stadium is probably, I don't know, 40 feet, so let's say 12 meters. And so I'm going to put in here 12 meters, and then I can calculate how much potential energy I have relative to gravity, potential energy due to gravity relative to the ground here. And that would be 80 times 9.81 times 12 meters, which is about 10,000 joules of energy. And that is the energy I have because I am in a gravitational field and I'm up above my reference line. So my reference line is 0 here, for example. And so because I'm above it, I have potential energy due to gravity, and that potential energy is about 10,000 joules. So that's an example. So what you're going to do is you're going to solve problems involving these three ideas. You're going to solve problems involving work, or finding the energy that's transferred by a force, finding the kinetic energy, which is the energy of motion, and finding the potential energy due to gravity, which is m times g times h. Okay, so find your homework and solve those problems.